So here's a quick refresher of some of the properties of the graph of a quadratic function. I mention this stuff often because it's stuff we need to memorize. So our vertex hk is negative b over 2a, and then if I plug that into my function, I'll get my k value. So that's our vertex. Our axis of symmetry is always x equals negative b over 2a, which is our h, right? That's our vertex, x's value. My parabola opens up as long as a is greater than 0. And then because my parabola opens up, the vertex is the minimum point, so it's the lowest value. If my parabola opens down, then I know that a is less than 0, so negative. And then our vertex is our maximum point. That's the highest point on my graph. So why don't we go ahead and graph the following. What I want us to make sure we do is state our domain, range, line of symmetry, and the maximum or minimum. You're only going to have a maximum or a minimum, not both. So we start by finding our vertex. That's what we're always going to want to do. So a equals negative 3, b equals negative 2, and c equals 1. So h equals negative b over 2 times a. That means I've got a positive 2 divided by negative 6, so I have negative 1/3. Next, I'm going to go ahead and pick and substitute in to find my k. So I've got my vertex. I'll write that down here. Vertex so far is negative 1/3. So now if I take f of negative 1/3, that'll give me my k. So negative 3 times negative 1/3 squared minus 2 times negative 1/3 plus 1. That gives me negative 1/3 squared, which is negative 3 times 1/9 plus 2/3 plus, we'll go ahead and write that as 3/3. Negative 3 times 9, that's negative 3/9, that's negative 1/3 plus 2/3 plus 3/3. I find my y value is 4/3. Okay, so when x is negative 1/3, y is positive 4/3. So it's right about here. This is my vertex. Okay, I need to go ahead and find 2 more points. Normally I'd pick ones that are like equidistant from our vertex, but our vertex is a fraction. So why don't I go ahead and find when x is 0 and when x is negative 1. So when x is 0, y is going to be 1. And when x is negative 1, y is going to be negative 3 plus 2 plus 1, which is 0. So here's our beautiful parabola. We want to always find 3 points. My axis of symmetry is the x value of my vertex, so that's x equals negative 1/3. My domain is negative infinity to positive infinity. My range, well, that goes all the way from negative infinity to 4/3. So we're going to go negative infinity to 4/3, and 4/3 is included. And the vertex is my maximum point because it opens down. And I knew it opened down because a was negative. For this next equation, I have 2x squared plus 4x plus 5. I'm going to go ahead and clear all of my notes so we can have a fresh graphing space. And we'll change colors. So we start out by labeling all our A, B, C's. H, the first point of my vertex, the x value of my vertex, is negative 4 over 2 times 2. So that's going to give me negative 1. My k is going to be f of negative 1, which equals 2 times 1 minus 4 plus 5. which is 2 minus 4, which is negative 2 plus 5 is 3. So when x is negative 1, y is 3. I know my parabola opens up. So let's go ahead and find 2 more points on our graph. Because my x value is a nice whole integer, I'm going to look at when x is 0 and when x is negative 2, knowing there's going to be some symmetry there. So when x is 0, y is 5. When x is negative 2, I'm going to have 2 times negative 2 squared plus 4 times negative 2 plus 5. Well, that's going to give me positive 8 minus 8 plus 5, so that's just going to give us 5. Like I said, we have some symmetry. Oops, make that a little smaller. So here's our beautiful parabola. Okay, it has a line of symmetry at x equals negative 1, so right through here. Its domain is all real numbers. Its range is what has changed, and so we look to see how our graph is shifted. Well, my y values start at negative 3, and then they go up, 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 up to infinity. So 3 is included. I'm at positive 3. The last thing I need to know is my vertex a maximum or a minimum? And my vertex is a minimum because my parabola opens up. This is the smallest value my graph could take on. So our minimum is my vertex when x is negative 1, y is 3. Another way we can find our vertex is by taking our function from f of x equals ax squared plus bx plus c form and transferring it into vertex form. And there are 3 steps we're going to do this. So 1, if a doesn't equal 0, we need to pull out a factor of a, right? Then what we're going to do is we're going to add b over 2 squared to both sides. That's what it says, square half of our coefficient of b, and add and subtract this to our equation. We're adding and subtracting it because if I add 2 and I take away 2, what did I really do? I added 0, so I had no real effect on our equation. I didn't do anything. Then we need to factor this trinomial as a perfect square and combine our remaining constants. So here I have f of x equals x squared minus 4x. Why did I write that so far away? Minus 4x plus 5. So a already equals 1, so I'm good with that step. The next thing I need to add and subtract b over 2 squared to both sides. So I'm going to add negative 4 divided by 2 squared minus negative 4 divided by 2 squared plus 5. What I want you to see is that this part right here, this is a perfect square trinomial, right? From what we know about completing the square, this is going to factor to x plus b over 2 squared. Okay? So this is going to factor to f of x equals x, b over 2 is negative 4 divided by 2, so that's minus 2 squared. Then over here I have minus negative 4 divided by 2, which is 2, negative 2 squared, which is 4. So I've got minus 4 plus 5. So f of x equals x minus 2 squared plus 1. So my vertex is when x is 2, y is 1. Let's do another example where a doesn't equal 1. So if a doesn't equal 1, we're going to want to pull out a factor of a from everything but the constant. So here I have f of x equals negative 3x plus 6x. So I have f of x equals negative 3 x squared minus 2x minus 1. Now I can go ahead and add x squared minus 2x, so I can add my negative 2 divided by 2 squared and subtract my negative 2 divided by 2 squared. And then out here, I have a minus 1. Note, I need to separate this from this. So I have f of x equals negative 3 times x minus 1 squared, because this is going to factor into our perfect square trinomial. Then I have negative 3 times this. Remainder right here. Negative 2 divided by 2 squared. Negative 2 divided by 2 is negative 1. Squared is 1 minus 1 is negative 1 minus 1. So f of x equals negative 3 x minus 1 squared plus 3 minus 1. So f of x equals negative 3 x minus 1 squared plus 2. So our vertex is when x is 1, y is 2. We can also find the formula of a function given its vertex and one other point. So if my vertex is hk and I know one other point on the function, I can solve for the vertex form of this function. So if I have a vertex of hk and I'm given a point on the graph, so that's the x and y intercept, so when x is 0, y is negative 3, I now have an hk value, an x value, and a y value. So I can solve for a. All we're going to do is substitute in to our equation. So I've got f of x, which is negative 3, equals a times 0 minus 1 squared plus k, which is a negative 5. So I have negative 3 equals a times 0 minus 1 is negative 1, squared is 1, minus 5. So I have negative 3 is a minus 5. I add 5 to both sides. I get that 2 equals a. So I can rewrite my equation as f of x equals 2 x minus 1 squared minus 5. So once we solve for a, we can write this in vertex form. Let's try this again. I have a function with vertex 1, 4 that passes through the point when x is negative 1, y is negative 8. So I have negative 8 equals a times x, which is negative 1, minus 1 squared plus 4. So negative 8 is a times negative 2 squared plus 4. So negative 8 is 4a plus 4. Subtract 4 from both sides. Negative 12 equals 4a. So I divide by 4 and see that negative 3 equals a. So my new function is f of x equals negative 3 times x minus 1 squared plus 4. We solve for our a and substitute in our h and our k.